Hi guys, so I finally have my camera back, yay! So, lesson 2.6, simplifying equations. And what we're doing in this lesson in 2.4, we did one-step equations. In 2.5, we did two-step equations. So in 2.6, we're going to have to simplify first, and then we'll solve the two-step equations. So let's go ahead and get started. It's on page 74 in your textbook. So, quick review of just simplifying equations. Actually, these are expressions. There's no equal sign. So simplifying our expression, we need to combine our like terms. So I have a 2x and a negative 5x, which will give me a negative 3x. And I have a positive 3 and a positive 18, which will give me a positive 21. Let's check ourselves, and that is correct. Going on to the next one, so we're distributing this time, so we have a negative 4 that we're going to multiply times each of these values here. So I have negative 4 times x will be negative 4x. Negative 4 times positive y will give me a negative 4y. And negative 4 times negative 3 will give me a positive 12. So I have negative 4x minus 4y plus 12. And on the last one here, we are distributing first. So we have positive 3 times x and positive 3 times negative 3. So positive 3 and a positive x will be 3x. Positive 3 times negative 3 will give us a negative 9. And then we still have our negative 8x. And then we're going to go ahead, we've gotten rid of our parentheses, we've distributed, so now we can combine our like terms. So I have a 3x and a negative 8x, which will result in a negative 5x. And then just our minus 9. And so we have negative 5x minus 9. Let's give these a try then. A couple more. Go ahead, try these on your own, then you can pause it, check your answers. So we have 4a minus 5 times the quantity of a plus b plus 3b. Before we can combine any like terms, we need to get rid of our parentheses, so we're distributing. If it helps you out, feel free to circle and draw your arrows. Remember, you're solving it. Just make sure you're showing your work. So minus 5a, or negative 5a times a, negative 5a. Negative 5a times b will be negative 5b plus 3b. And then let's check out our like terms. So I have a positive 4a and a negative 5a. That results in a negative 1a, or we could leave the 1 off. We could just say negative a. And then a negative 5b and a positive 3b, which will result in a negative 2b. So like I said, when you have a 1 in front of your variable, you can just leave the 1 off. So it's just a negative a minus 2b. Make sure you're really careful with your b's and your 6's. You don't want them to get confused. And then last one here. First, we have to get rid of our parentheses. So we'll distribute. So we'll have 7m plus 14. And copy down our 12 minus 8m, and this was a positive 7, so we have a plus sign here. And then combine our like terms. So we have a negative 8m and a positive 7m. That will result in a negative m, or a negative 1m. And then 12 plus 14 will give us a positive 26, or plus 26. We have negative m plus 26. So those were simplifying expressions. Now we're going to look at simplifying equations. So you can use the distributive property to remove parentheses. You might need to combine like terms inside of your parentheses also, so you might need to use your distributive property to combine like terms. So example 1 says solve 3x plus 2 plus 5x minus 7 equals 28. So the first thing we need to do is combine our like terms. So I have a 3x and a 5x, and we're only combining on each side of the equal sign. So if you want to do kind of a dashed line, so you know like terms on this side, and then if there were multiple terms, you could combine on the other side, but we're staying on one side for right now. So 3x and 5x, and then a positive 2 and positive 2 and a negative 7. We combine those and get 8x minus 5 equals 28. And then now that we've combined our like terms, we'll go ahead and solve it. So first things first, adding 5 to both sides. to get rid of our 5, so a negative 5 and a positive 5 will give us 0, so we have 8x, and then 28 plus 5 is 33. Then we'll divide each side by 8. So we have 8x over 8 equals 33 over 8. Our 8's cancel, and we have x equals 33 over 8. Then always remember, did you check your answer? So go back, plug it into a calculator. 3 times 33 over 8 plus 2 plus 5 times 33 over 8 minus 7 equals 28. You have to remember to use your order of operations, though. You can't just punch it in a calculator straight across like that, because it won't work out for you. Example 2. Solve 3 times the quantity of x plus 1 minus the quantity of x minus 2 equals 13. So first things first, we can't start to combine our like terms until we get rid of our parentheses. So we're going to distribute. We'll get 3x plus 3. Then remember, there's like an imaginary 1 out in front here that we're distributing. So negative 1 times x and times negative 2. So negative 1 times x will give me a minus x. Negative 1 times negative 2 will give me plus 2 equals 13. Remember, here's our dashed line. So we're going to combine our like terms now. So we have a positive 3x and a negative x gives me 2x. Then I have 3 plus 2 will be 5 equals 13. Now, we have all of our terms combined, so we're working to get our x all by itself. So first we want to eliminate our tag along, our little brother here. Whoops. Hang on here. Let's grab the eraser. That should be a minus sign. Okay. So we have minus 5 on each side because we're doing the inverse operation. So we'll end up with 2x equals 8. And then divide by 2 on each side because we have 2 times x. So we want to do the inverse operation. And our 2's cancel. We end up with x equals 4. And then, of course, go back, check your answer. You might even be able to do this one in your head. So let's just say 4 plus 1, well, that would be 5. 3 times 5 is 15. And then minus 4 minus 2 is 2. And 15 minus 2 equals 13. So that's good. We check out. All right, example 3. So example 3 is a word problem, so we're going to have to do some translating here. So John's mother is 4 times as old as John, and John's brother is twice as old as John. If you find the sum of their ages and add 3, you get 80. What are the ages of all 3 people? So the first thing we have to realize is each time they talk about someone's age, they refer it back to John. They relate it to John somehow. So John is going to be our main variable. So we could use a J for John. I'm going to use X just because that's what I like to do. Up to you. But we need to establish this is what it stands for. So X is John's age. And then it says John's mother is 4 times as old as John. Well, if John's age is X and his mom is 4 times John's age, is going to be 4x. So 4x will be John's mother's age. And then the third person is John's brother, and it says John's brother is twice as old as John. So if John's age is x and John's brother's twice as old as him, it's going to be 2 times x, or 2 times John's age will be John's brother's. And then after that it says if you find the sum of their ages and add 3, you get 30. Or sorry, you get 80. So the total is 80. So we need to first add, here's John's age, and this is John's mom, and this is John's brother, and it says add all of those things up, add each of their ages up, and then add 3, so there's our plus 3. So John's mother plus John's brother plus John plus 3 equals 80. And that's what we've translated here. We found John's mother, 4x, John's brother, 2x, John is x, and then add 3, and we will get 80. And now we can solve and find out how old each of these people are. So first things first, let's combine our like terms. We have a 4x, a 2x, and an x. 4 plus 2 is 6, and another one is 7. So we have 7x, then we have our plus 3 equals 80. And now we can solve. So first things first, 7x, we're going to subtract 3. I'm going to go ahead and do this over here, because if not, I'm going to run out of room on my slide. So 7x plus 3 equals 80. We're going to subtract 3 from each, so we get 7x equals 77. Divide by 7 to get our x all by itself. We end up with x equals 11. All right, so x equals 11, that's what the answer is in the book, so we should be pretty good so far. So then we have to say, well, what was the question asking us? It says, what are the ages of all three people? So it didn't say solve for x. It says, what are their ages? So if x was John's age, that means John is 11 years old. John was 4 times John's age, so that means John's mother is 44. And John's brother was twice his age, so that means John's brother is 22 years old. And now we've answered the question because we had to talk about all three of these people's ages. And we should, of course, go back and double check. So if we add 22 and 44, we get 66, and add 11, we get 77, plus that 3, that gives us 80. So our answer does check. So we are good to go. Converting a repeating decimal to a fraction of 2 integers. So this lesson is kind of broken into 2 different parts. So the first thing we did was learning how to simplify and solve equations. This is something kind of separate. They're teaching us how to turn repeating decimals into fractions, which is pretty fun. It's cool to see. So first you need to write an equation in which x is equal to the repeating decimal. Stick with me here on these rules. They're kind of wordy, but it's a lot easier once you see it done. Use the multiplication property of equality to multiply both sides of the equation by 10 to the nth power, where n is the number of repeating digits. Again, just stick with me through this. And then subtract the original equation from the new equation formed by the multiplication. This step is an application of the addition property of equality since we are subtracting equal quantities from each side of the equation. Then solve the resulting equation and reduce the fraction into lowest terms. All that to say, let's just do one. I promise you it'll make a lot more sense. So, we want to change 0.36 repeating as a quotient of integers. That just means we want to write it as a fraction. So a quotient of integers means write it as a fraction. That's W, right? As a fraction. So, first thing they said to do was set our repeated decimal equal to x. Easy enough. X equals our repeated decimal. That's all we have to do. Then they say, multiply each side by a value of a power of 10. So either 10 or 100 or 1,000 or so on, depending on how many digits we have after the decimal. So here, how many repeating digits we have. So we have 2 repeating digits. So we're going to multiply it by the power of 10 that has 2 zeros. So we're going to multiply this side by 100, and we're going to multiply this side by 100. So it'll look like 100x equals 36.36. Remember, when we multiply by 100, we're just kind of moving our decimal, and remember, this is repeating, so there'd be 3 6s going on forever here. So when we move our decimal 2 places, we end up with 36 and 36 repeating, which we have here, 36 and 36 repeating. Then the next step said we're going to subtract a repeating part, or the value of x, from each side. So on our x side, we'll subtract x, which is equal to 0.36. On this side, we're going to subtract 0.36 because that is equal to x. So we are using our additional property of equality, which applies to subtraction, and we are technically subtracting the same value from each side because we said that x is equal to 0.36. So since these are equal, and then all that's left to do is go ahead and solve it. So we're going to subtract our 100x minus x. Well, that gives us 99x. And then we're going to subtract our 36 and 36 repeating, and subtract our 36 repeating from that, or 0.36 repeating from that. And we're left with 99x equals 36. And then the last step to solve a multi-step equation is just to divide. We want to get the x all by itself. We were multiplying, so we're going to divide each side by 99. That gets rid of our 99s, and we end up with x equals 36 over 99, which actually reduces to 4 over 11. So if we wanted to write 0 and 36/100ths as a fraction, it would be 4 over 11. And I'd encourage you to go ahead and put 4 divided by 11 in your calculator, and that lets you see that it is 0.36 repeating. And then example 5, so one more of these, but this time instead of having 2 digits repeating, we just have 1, so you can see the difference. So first step, set our repeating decimal value equal to x. So we have x equals 1.36 with just the 6 repeating. And then remember the next step was we had to multiply by a power of 10, so either 10, 100, 1000, depending on how many digits we're repeating. Well, there's only one digit repeating this time, so we're going to multiply by a power of 10 with only one 0, so we're going to multiply each side by 10. So we get 10x equals 13.6 with the 6 repeating. Then we're going to subtract a value of x and the value of our 1.36 with the 6 repeating from the 10x equals 13.66 repeating. Remember, we're allowed to do that because of the addition property of equality, which says as long as you do onto one side what you do onto the other, we're good to go. And because x is equal to 1.36 repeated and 1.36 is equal to x, we are subtracting the same values from each side. Then we can subtract 10x minus nx would be 9x. 13.6 with the 6 repeating minus 1.3 with the 6 repeating would be 12.30. You'll notice every time we do this subtraction step, there's no more repeating. So that's kind of essentially what we're doing. We're eliminating our repeating digit. And then last step is just to divide to get our x all by itself. That cancels out our 9s, and we're left with x is equal to 12.3 over 9. One final thing we have to do, though, we should never leave a decimal in a fraction, so we're just going to have to multiply each one by 10 or move our decimal over 1 in each, and that gives us 123 over 90, which reduces to 41 over 30. So if we wanted to write 1.36 with the 6 repeating as a fraction, it would be 41 over 30. And again, you can check this by putting 41 divided by 30 in your calculator, and you'll get 1.36 with the 6 repeating. All right, so that's it for lesson 2.6. Go ahead, check your assignment, and let me know if you have any questions.